This is activity number 3 from lab 6. I'm solving a problem with shell elements. Uh, we have a shell of these dimensions and a thickness of 0.1. The top face is being loaded, the bottom edges are clamped, and you're asked to use as many planes of symmetry as possible. So I'm going to cut this thing 2 ways. So take 1/4 of that. However, I'm going to assume that the top face, this top face, has a thickness of 0.1, but the side faces, that means this vertical plate, has a different thickness. So let's say half of what's on the top. Now, I did the problem twice in activities 1 and 2, but you may want to look at that if you wish. However, here I'm going to assume that the top and the side have different thicknesses, and one of the ways that I can do that is create this uh, edge, L-shaped edge, extrude it to create the surface. Right away, a single surface composed of 2 pieces is created. I don't have to join it. It's not necessary because they are the way it's constructed. They are already seeing each other. And then when it comes to meshing, I will put a thickness of 0.1 as 2D property on that surface that I create and use the local 2D property in order to change one of the thicknesses. Okay, so let's go ahead and do this. Since I'm dealing with surfaces only, I'm not going to create a three-dimensional block. So I am in, this is generative shape design. You can do this thing in the wireframe and surface design too, but this is the more mature version of wireframe and surface design workbench. So here I'm going to draw the L, just like I did in activity 2. Where is that? Okay, so let's make this thing vertical. I don't think it's vertical here. Vertical, very good. Now dimension these things. So let's see, now this is going to be 2, and the side one is going to be 0.5. Okay, exit and extrude it. Actually, this was a mistake. This was 1, not 2. This is 1. Yep. Exit and extrude it by 2 inches. But the direction doesn't matter because, okay, there we are. All right. So this is 1/4 of that folded sheet metal that you can see. Why don't we apply material to it? Apply material, yellow brass. What is that? Yellow brass metal. Yellow brass on this. And by the way, as I said, you don't have to join these things because of the way you constructed them. In activity 4, I'm going to create the same thing, except that extract the faces, and when you extract it, then you have to join it. Otherwise, when you mesh, there's going to be duplicate nodes along that line. Okay, very good. We're pretty much done here, so we're going to go to analysis and simulation. No fancy mesh. We don't go to advanced meshing tool, generative structure analysis. We say OK. Let me change the rendering here. There we are. Now this is, by the way, this thing on the side is a sketch. If you don't want to, you can hide it. Okay, very good. I did. Now, first we're going to mesh it with the shell elements right there. 3-noded shell element. Catia calls it octave triangle mesher. There we are. I'll keep the size the same. The type was parabolic before. I'll keep it like that, no problem. Now we have a 2D property. This is a 2D property. Click on it, select this, and notice that because these surfaces, because of the way it was constructed, that 0.1 also applies to the side. Everything is 0.1. We say OK. However, when you go to properties here, you can right click. It says local 2D property right there. Just like we had local 1D property for mesh, so we select this face and then we can put whatever we want. So thickness of 0.0 0.05. Uh, yeah, there we are, 0.05. Notice that the top face is 0.1. It was 0.5 for the side too, but when we do local on the property, you can go and change the face that you want. Okay. The rest is exactly what we did before, but I'll repeat it anyway. So this bottom is clamped. Let's say this face and this edge and this edge lie in the exit plane of symmetry. So we go user defined, uncheck everything. These two lie in the exit plane. As soon as say exit plane, no displacement in Y, rotations opposite. This other edge, let's uncheck everything here. Okay, this other edge lie in the YZ plane, immediately no displacement in Z, in X. When you say YZ plane, no displacement in X, rotation is opposite. And then we apply a pressure of 100 psi on the top. Now, you may want to fool around with the sign here. If it doesn't match what you want, you have to flip these, okay? The user has a control over the direction of these arrows, whether it's on the top or the bottom and what direction it also goes. But I'm not going to fool around with this, except that you should be aware of the fact it can be done. Good. That's pretty much it. And it's going to run and I mean, I'm not guaranteeing that these results are going to be identical to what we got before because we have to do a mesh convergence study in order to select a good mesh, and we didn't do that. So here's a deflection. Let me change this thing to average ISO and change the rendering to material shading, and there we are. And obviously you can animate. It's the same problem as before. So I'm going to repeat this in activity 4, except that I will create a box and extract the faces, and there you have to join, because if you don't join, when you mesh them, there will be duplicate nodes along that edge. I will show you in activity number maybe 4.5, or activity number 4.5, how to create analysis connections in order to tie them if you decide not to join those surfaces. Okay, so that wraps up this particular activity.